हेलो एवरीवन, वेलकम टू टीओसी क्लास। पहले ये कंफर्म करना कि ऑडियो क्लियर है, वीडियो क्लियर है और मैं हैंडसम हूं। प्लीज कंफर्म इफ द ऑडियो इज क्लियर, वीडियो इज क्लियर एंड आई एम हैंडसम, देन वी विल स्टार्ट द क्लास। ठीक है। दरवाजे को गुंडी मारे कोई ना अंदर आने पाए, आरबीआर को समझा दे म्यूजिक गलती से भी रुक ना पाए, टकर टकर जो फील करे जाके 2 कप कॉफी पी ले, जिसको डांस नहीं आता है जाके अपना बेस्ट चराए। टुडे वी आर गोइंग टू डू very very interesting topics. Okay, you will fall in love with today's class. And एक बार, can someone in telegram send me what was the last page in your notes? Can someone in telegram send me what was the last number in the notes? I am on telegram. Can someone tell me what was the last page? What was the last problem? What was the last problem? Do you know about Verghese Kurien? Do you know about Verghese Kurien, who is called the milkman of India? Initially, in the early 1990s, he was born in 1921 and he died in 2012, and he led Operation Flood. इसका ऑपरेशन बोलते हैं फ्लड, from 1970 to 1996. Initially what happened was, in the villages there used to be farmers and they used to have cattle and they used to produce lot of milk, but then getting that milk to cities was a challenge. The milk used to get spoiled. Then this hero Verghese Kurien, what he did was, he invented methods like pasteurization, cooling. He invented pasteurization, chilling centers, and transparent pricing. Now, India used to produce 20 tons of milk from 20 tons, only 20 tons of milk. From there, he brought it to a level where India was producing 50 million tons. He has connected all the villages with cities and towns, and the milk was delivered, right? So he boosted the income of rural people and the nutrition. Kurien's blend of engineering rigor and social vision transformed India into the global leader in milk production. Global leader in milk production. He is a hero. He is an Indian. I am proud to be an Indian. Jai Hind. Jai Hind. Jai Hind. I am proud to be an Indian. ठीक है. So what was the last problem we discussed yesterday? A power n, B power n such that m plus n equal to 10 है ना? Okay, we will start from there. So we will start with this. Yesterday I have given you the question a power m, b power n such that m plus n equal to 10. What was this language? What was this language? बाद में ना कहना कुछ भी, पहले दे दू वार्निंग, पार्टी चलेगी टिल 1:30 AM. बाद में ना कहना कुछ भी, पहले दे दू वार्निंग, पार्टी चलेगी टिल 1:30 AM. ठीक है. तो a power n, b power n, m plus n equal to 10. What language is it? Can someone tell me what language it is? Can someone tell me what language it is? Very good. Very good. This is a regular language. This is a regular language, right? This is a regular language, right? Right. Why is it a regular language? Because it is finite. Because it is finite. Right? If I write like this, a power n b power m such that m plus n is less than 10. M plus n is less than 10. What language is it? It is regular, right? If you see m plus n equal to 10, we have only finite number of solutions. 0 10 हो सकता है, 10 0 हो सकता है, 1 9 9 1 2 8. If you write like this, you will get only finite combinations. Therefore, the language is finite. That is why it is regular. Now, if I say m plus n is less than 10, what kind of language is it? M plus n is less than 10. What kind of language is it? M plus n is less than 10. What kind of language is this? What kind of language is this? Very good. ये है finite है ना? What will you get here? M plus n is less than 10. Otherwise, m plus n is less than 9. Otherwise, m plus n is less than 8. M plus n is equal to 9, equal to 8, equal to 7, so on. M plus n is equal to 0, right? So these are all finite. These are all finite, right? So the language is regular. So the language is regular. These are all finite. So the language is regular. Regular. ठीक है? So a power n b power m such that a power n b power m such that m plus n is less than or equal to 10. M plus n is less than or equal to 10. A power n b power m such that m plus n is less than or equal to 10. M plus n is less than or equal to 10. What type of language is it? What type of language is it? Very good. So m plus n is less than or equal to 10, which means m plus n is 10. Otherwise, m plus n equal to 9. Otherwise, m plus n equal to 8. Otherwise, m plus n equal to 7. So on, m plus n equal to 0. So on, m plus n equal to 0. है ना? So these are all finite. This is a finite language. This is a finite language and it is regular. And it is regular. ठीक है? Now I will give you some question. Now I will give you some question which no one will be able to answer it. I'll give you some question. A power n, b power m such that n is not equal to m. Such that n is not equal to m. Not m is not equal to n. We will say m plus n not equal to 10. M plus n not equal to 10. I will give you 5 minutes of time. M plus n not equal to 10. I will give you 5 minutes of time. I will give you 5 minutes of time. Anyone can give me the proof for this. If it is regular, give me the proof. If it is not regular, give me the proof in Telegram channel. If anyone can answer this question, if anyone can answer this question, they will get into top 100 if they work hard. If anyone can answer this question, they will get into top 100 if they work hard. Okay? I am giving you 5 minutes time. Write your answer in Telegram. If anyone is able to answer this, you will get into top 100. Okay? You will get into top 100. try it. You are 50% right. Don't give up, just try. You are almost 50% right. Okay? Don't give up. You are almost 50% right. Try it. Try it. Try it. Don't give up. Okay? Try it, guys. Okay. Shall I explain? Shall I explain? I will take using complement. Okay. A power n, b power m such that m plus n is not equal to 10. I will take the complement of it. What do I get if I take the complement? A power n, b power m such that m plus n, a power m, b power n such that m plus n is equal to 10. You will get something extra here. This part is clear. Not equal to 10, equal to 10. This part is clear. You will get something extra here. You will get something extra here. If someone can write it down in Telegram channel, they will get below 100 rank. If someone can write it down in the Telegram channel, they will get below 100 rank. This is not the complement. You will get even more strings. This is not the complement. You will get even more strings. Guys, some people are asking me about my life story. I have done my life story on my channel, Professor Ravindra Babu Ravla. Go to the channel Professor Ravindra Babu Ravla. There is a video called Life Story of RBR. You please watch that video. You will know my life story. Okay? You will go. If you watch that link, if you watch that video, you will know my inspiring story. Okay? Have you given up? Shall I explain? No one wants to try. No one wants to try. Try it, guys. Try it, guys. A power n, b power m such that m is not equal to 10 is equal to a power n, b power n such that m is equal to 10. Union kuch to aayega. You are going to get something here, right? See this, guys. Here, b's are always after a's. You will never see a BA. after a B, you will never see a A. Therefore, all the strings containing BA are also in the complement of this language. Matlab, all the strings containing BA, A plus B star, BA, A plus B star. This is the complement. This is the complement. If I take the complement of A power n, B power m such that m plus n equal to 10, what is the complement I am getting? A power n, B power m such that m plus n equal to 10 union A plus B, BA, A plus B star. A plus B star, BA, A plus B star. A plus B star, BA, A plus B star. A plus B star, BA, A plus B star. Okay. Anyone understand? Are you able to understand this? See, m plus n is not equal to 10. Therefore, m plus n equal to 10 will be in the complement. Along with that, there will be strings which are containing BA also in the complement. Why? Because in this language, there will be no BA. After a B, there will be no A. Only A's followed by B's are there. Therefore, A plus B star, BA, A plus B star is a one of the language, right? Now we know that this is finite. This language is finite and this language is regular. And this language is this is a regular expression, right? So this language is regular. Now if I union two regular languages, then the result is a regular language, right? Now complement of a language is regular. Complement of a language is regular. Complement of a language is regular. Therefore the language is regular. Therefore, the language is regular. Complement of a language is regular. Therefore, the language is regular. Understood this? Everyone got it, or should I explain it again? Everyone got it, or should I explain it again? Okay. Answer this question. Answer this question. A power m, B power n such that m is greater than or equal to n. Otherwise, we'll write like this. M plus n is greater than or equal to 10. M plus n is greater than or equal to 10. Answer this question. The beauty of 12 a.m. is your day has ended and a new day has started. You ended the day with me and you have started a day with me. I am happy that all of you are still awake and watching it. Sir, if complement is regular, then language is regular. Yes. If a language complement is regular, then the language is regular. Can someone say the proof in Telegram channel? Can someone send the proof in Telegram channel? Can someone send me the proof in Telegram channel? No one is able to give the proof. These are not very simple questions. These are somewhat difficult questions. But if you are able to do these questions, you will do well in GATE. If you are able to do these questions, you will do well in GATE. If you are able to do these questions, you will do well in GATE. Okay. These are not very easy questions, but you can do well in GATE if you do these questions. Okay. Debolina, half of it is right. Aniruddha, half of it is right. Some people are saying that it is non-regular. Okay, I'll give you a hint. This is regular, prove it. This is regular, prove it. I have given you the hint also that this is regular, and now you have to prove it. This is a regular language, and now you have to prove it. Okay, I'll prove it. I'll take the complement. A power m, b power n such that m plus n is greater than or equal to 10. If I take the complement, what do I get? I get a power m, b power n such that m plus n is less than 10. Here it is greater than or equal to 10, right? M plus n is less than 10. Union, there are some strings which are not in this language. Strings containing BA. It is always A's followed by B's. B will never be followed by A in this language. Therefore, these strings will also come in complement. Okay? So, what can I write? A plus B star, A plus B star, BA, A plus B star, A plus B star BA, A plus B star, A plus B star. Right? Now, this is a finite language. This is a finite language. Therefore, this is regular. Finite language is regular. What about this? This is the regular expression. This is the regular expression. Therefore, the language is regular. Now, union of two regular languages is regular. If I take union of two regular languages, then it is regular. Union of two regular languages is regular, which means complement of a language is regular. Therefore, the language will also be regular. एक point याद रखना. Just remember this point. Note, if R is, if L is regular, then L complement is regular. If L complement is regular, then L is regular. Right? And one more point is both L and L complement are either regular or non-regular. Both of them will be either regular or non-regular. If L is regular, L complement will be regular. If L complement is regular, L will be regular. If one of them is not regular, then we can't say. Okay. I will show you this. I will give you RBR tables. You will be able to understand. So what is this language, guys? This language is regular. This language is regular. Okay, this language is regular. What are the questions we have solved? Not equal to, greater than, or equal to, right? Now I will give you one more question. A power m, b power n such that m is greater than 10. M plus n is greater than 10. Answer this question. M plus n is greater than 10. Okay. So I will tell you a story of a person. Arogyaswami Paulraj. Arogyaswami Paulraj. So Arogyaswami Paulraj, he was born in 1944 and he invented MIMO, multiple input and multiple output technology in 1992. In 1992, he has invented MIMO, and at the Indian Institute of Science. He invented this at the Indian Institute of Science, Bangalore, right? Being a IIScn, I am very proud to say that one Indian has changed the entire internet. And because of his technology, now we are able to boost the data rates, and even LTE and Wi-Fi all are based on his patents. And in IIT Madras, he has applied for many patents and he has got many patents. Now, high speed internet and high speed mobile broadband, everything is based on his work, and he has received number of IEEE papers and the government honors for revolutionizing wireless communication. He is an Indian, and he did everything in IISc, and I am proud to be an Indian. Jai Hind. Jai Hind. Jai Hind. Okay. Okay, guys. Is it regular or not? Is it regular or not? Tell me, is it regular or not? Very good. This is regular, right? How is it regular? How is it regular? I will take complement of it. A power n, b power n such that m plus n is greater than 10. I will take complement of it. I will take complement of it. Okay. I will take complement of it. Then what do we get? If I take complement of it, then what do we get? One is for sure. You will get a power m, b power n such that m plus n is less than or equal to 10. It is for sure. Less than or equal to 10. It is for sure, right? And what is this language? This is finite language, and therefore this is regular. This is finite language, therefore it is regular. Okay. Now you will get even more languages. What are the even more strings you will get? Here BA will not be present, therefore you will get BA, right? You will get A plus B star followed by BA followed by A plus B star. A plus B star followed by BA followed by A plus B star. A plus B star followed by BA followed by A plus B star. This is the regular expression, right? And therefore this is regular, and union of two regular languages is regular. So this entire part is regular. What is this part? Complement of this language. Complement of a language is regular. Therefore the language itself will be regular. The language itself will be regular. The language itself will be regular. Okay? Now I'll give you one more question. A power m, b power n such that 2m plus 3n is equal to 500. 2m plus 3n is equal to 500. 2m plus 3n equal to 500. Two m plus 3n is equal to 500. Very good. This is finite language, right? I will put 2 into 100 plus 3 into 100. This will be equal to 500, right? Or I will put 2 into I'll put some number 2 into 50, which is 100, and then 3 into some number, whatever numbers I put. This is a finite language, right? This is a finite language, therefore this is regular. Therefore this is regular. This is a finite language, therefore it is regular, right? Right? Now, if I write like this, a power m, b power n, such that m minus n equal to 10. M minus n equal to 10. M comma n is greater than or equal to 0. M comma n is greater than or equal to 0. A power m, b power n such that m minus n equal to 10 and m comma n is greater than 0. M comma n is greater than 0. Is this finite? This is an infinite language, right? I can put 100 here and I can put 90 here. I can put 101 here. I can put 91 here. I can put 102 here. I'll put 92 here. 92 here. Right? So on. So this is a infinite language. This is a infinite language, right? Actually, m minus n equal to 10 can be written as m equal to n plus 10, which means the number of A's, the number of B's should be 10 more than number of A's. Therefore, this is not regular. This is not regular. This is not regular. But subtraction can be done by context-free language. Therefore, this is context-free language. Therefore, this is context-free language. Therefore, this is context-free language, CFLA. This is context-free language, which is CFL. Context-free language, which is CFL. Which is CFL. Okay. Now, any model you take here, all are non-regulars. If I write like this, a power n, b power n such that m minus n equal to 10, otherwise m minus n equal to m minus n is less than or m minus n is not equal to 10, m minus n is less than 10, m minus n is less than or equal to 10, m minus n is greater than 10, m minus n is greater than or equal to 10, m minus n is greater than or equal to 10. All these languages are not regular languages. All these languages are not regular, but all of them are context-free languages, because I told you that context-free languages can do subtraction. Context-free languages can do subtraction. Context-free languages can do subtraction. Right? 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 Now do this. A power m, b power n such that m into n equal to 10. M into n equal to 10. Is this regular or non-regular? A power m, b power n, m plus n into 10. You have to dance with these problems. These problems are so exciting that they will give you stimulus intellectually, right? You should dance to my tunes. नाच नाच के तोड़ दे बेबी, जी भर के नाच ले बेबी, नाच नाच के तोड़ दे सैंडल, आंटी पुलिस बुला लेगी तो आरबीआर कर लेगा हैंडल. ठीक है? ठीक है? These are all interesting problems. Very interesting problems. Can you say whether this is regular or not? Can you say whether this is regular or not? M into n equal to 10. Whether this is regular or not? Whether this is regular or not? Actually, this is a finite language. Actually, this is a finite language. M into n equal to 10. It can be written as 5 into 2 or 2 into 5. It can be written as 5 into 2 or 2 into 5. 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 Okay. Okay. This is finite language. So this is regular. ठीक है? ठीक है? Now you can do the same for this. A power m, b power n such that m into n not equal to 10. Is this regular? M into n is not equal to 10. Is this regular? Is this regular? M into n is not equal to 10. Is this regular? Is this regular? Is this regular? Very good, Satyam. Very good, Shashank. So you can take the complement of it, right? If I take the complement of it, what do I get? I get a power m, b power n such that m into n is equal to 10 union I can write like this: a plus b star ba, a plus b star, a plus b star ba, a plus b star, right? So m into n equal to 10 and this one, both of them are regular, right? So this is regular and this is regular. Both of them are regular. Union of two languages is regular. Here, union of two languages is regular. Union of two languages is regular. Right, right. Therefore, the entire complement is regular. Therefore, the language will be regular. Right? So, don't apply the rules blindly. Whenever you see multiplication, don't say that it is CSL. There are chances that it will be regular also. Whatever rules I am saying, RBR rules, you have to be careful while applying them. Sometimes you get regular languages also. Sometimes you get regular languages also. Okay? Sometimes you get regular languages also. Now tell me for this. A power n, b power m such that m into n is less than 10. M into n is less than 10. m into n is less than 10. Is this regular or non-regular? A power n, b power n such that m into n is less than 10. M into n is less than 10. M into n is less than 10. Very good. Very good, Shashank. Very good, Abhindu. Very good, Aniruddha. Very good, Arun. Very good, Satyam. Sanu. Very good. Very good, Deborana Biswas. So this is actually finite language, right? This is actually finite language, and therefore this is regular. Therefore this is regular. If I give a language like this, a power n, b power n such that m into n is less than or equal to 10. M into n is less than or equal to 10. Less than or equal to 10. What can you say about this language? M into n is less than or equal to 10. What can you say about this language? Very good. Very good. Very good. Very good. So this language is finite, है ना? This language is finite, therefore it is regular. This language is finite, therefore it is regular. ठीक है? Now you tell me about this. A power n, b power n such that m into n is greater than 10. M into n is greater than 10. M into n is greater than 10. Tell me about this. M into n is greater than 10. M into n is greater than 10. Very good. We can take complement of it, right? Now what I will do is, I will take complement of it. A power n, b power n such that m into n is greater than 10. If I take a complement of it, then what do I get? A power m, b power n such that m into n is less than or equal to 10. M into n is less than or equal to 10. Union, you get more languages. You get BA, right? So A plus B star followed by BA followed by A plus B star. A plus B star followed by BA followed by A plus B star. A plus B star followed by BA followed by A plus B star. Okay. Okay. So what is this? This is finite language. Finite language. And what is this? This is regular. What is this? This is the regular expression. And what is this language? This is regular, right? Regular union regular is regular. Regular union regular is regular. Hana, which means this entire thing is regular. And complement of the language is regular. Complement of language is regular. Complement of language is regular. ठीक है? So what have we done? Equal to 10 we have done. Less than we have done. Greater than we have done. Less than or equal to we have done. We have to do greater than or equal to, right? A power m, b power n such that m into n is greater than or equal to 10. m into n is greater than or equal to 10. Do for this, m into n is greater than or equal to 10. Do for this, m into n is greater than or equal to 10. Very good, Shashank. Very good, Aniruddha. Very good, Abanti Ghosh. Very good, Roshan. Very good, Sanu. Very good, Riley. Satyam, very good. Debolina Biswas, very good. Manish Dakar, very good. Very good. You all have answered it correctly. 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 M into n is greater than or equal to 10. M into n is greater than or equal to 10. Right, right. So take the complement of it. A power n, b power n such that m into n is greater than or equal to 1. Take the complement of it. What do I get? I will get a power m, b power n such that m into n is less than 10, which means this is a finite language and this is regular, right? Union, I want to union this with a plus b star, a plus b star, a plus b star. I want to union it with a plus b star, a plus b star. This is regular expression, therefore this is regular. Union of two regular languages is regular, which means this entire complementation is regular. If this entire complementation is regular, this is going to be regular. This is going to be regular, right? Right? Now I will give you a question which you won't be able to answer. I'll give you a question which you will not be able to answer. But if anyone can give me proof in Telegram channel in 5 minutes, they will get a rank within 100. If anyone is able to give you the answer in 5 minutes, they will get a rank within 100. Okay. So let's do this. A power m, b power n such that m by n is equal to 10. M by n equal to 10. If anyone can prove this, you will get a rank under 100. M by n equal to 10. Okay. Take 5 minutes time. Don't answer directly. I will ask your answer after 10 minutes. Then you answer me. Okay. Then you answer me. No one will be able to answer it. I will answer it, okay? So actually m by n equal to 10 means, how can you write it? M equal to 10n, right? Now there is a comparison. You have to compare, and regular languages cannot do this comparison, isn't it? If m equal to 100, n equal to 10, otherwise m equal to 1000, n equal to 100. So this is a infinite language. This is a infinite language. Okay, m equal to n is infinite language, and infinite comparison finite automata cannot do. Why? It cannot, it obviously cannot compare this. Finite automata cannot compare this, right? So this is definitely not regular. This is definitely not regular, but this is context-free language. I will show you why this is context-free language when we go to context-free languages later, right? When we go to context-free languages later, I will show you why, right? So similarly, you can write the same thing. A power m, b power n such that m by n is equal to 10, m by n is less than 10, m by n is less than or equal to 10, m by n is greater than 10, m by n is greater than or equal to 10, m by n is not equal to 10, right? All these languages fall under context-free languages. All these languages are not regular. All these languages are not regular. All these languages are not regular. All these languages are context-free languages, right? All these languages are context-free languages. Because why it is context-free languages? If you take m equal to 10n, then there is only one comparison involved. When there is only one comparison involved, context-free language can do. And of course, if it is context-free language, this is context-sensitive language also. This is context-sensitive language also. Don't apply RBR rules directly. Use your common sense and then apply the rules. Okay? Okay? Now we will go to RBR rules. RBR rules. Rule number 2C. RBR rules. Rule number 2C. A rule number 2C. What does this say? When the language is infinite, regular languages cannot do any comparison. Regular languages cannot do any comparison, right? And context-free languages can do comparison, but only one comparison at a time. One comparison at a time. One comparison at a time. Right, right. And context sensitive languages can do any number of comparisons. Any number of comparisons. Any number of comparisons. Now using my rule 2C, you will be able to answer many questions. Okay. Let us take an example. A power m, b power n such that m comma n is greater than or equal to 0. A power m, b power n such that m comma n is greater than or equal to 0. What language is it? A power n, b power m such that m comma n is greater than or equal to 0. What language is this? What language is this? What language is this? This is infinite for sure. Aniruddha, you are right. It is infinite for sure. Aniruddha, you are saying that this is non-regular. Okay, Aniruddha has changed this answer. Regular. Very good. Aniruddha is saying that the answer is A star B star. Hai na? So this language is A star B star, which is regular. A star B star, which is regular. If I write like this, A power n, B power n such that n is greater than or equal to 0. A power n, B power n such that n is greater than or equal to 0. What language is it? a power n, b power n such that n is greater than or equal to 0. What language is it? What language is it? What language is it? A power n, b power n such that n is greater than or equal to 0. What language is it? What language is it? So there is comparison. There is infinite comparison. Therefore, regular languages cannot do infinite comparison. But there is only one comparison at a time. है ना? There is only one comparison. Therefore, this is context-free language. Therefore, this is context-free language, right? Now, if I write like this, a power n, b power n, c power n such that n is greater than or equal to 0. A power n, b power n, c power n such that n is greater than or equal to 0. Very good, Satyam. Satyam Raj, very good. Satyam Raj, very good. A power n, b power n, c power n such that n is greater than or equal to 0. A power n, b power n, c power n such that n is greater than or equal to 0. This is infinite language. So, one thing is for sure, this is infinite language and regular languages cannot do infinite comparison. Regular languages cannot do infinite comparison. This is for sure. Okay. Now, there are more than one comparison at a time. There are more than one comparison at a time, isn't it? There is more than one comparison at a time. There is more than one comparison at a time. Right? Therefore, context-free languages cannot do it. So only context-sensitive languages can do it. Okay. Now I'll give you one more question. A power n, b power n, c power n, d power n such that n is greater than or equal to 0. Answer this. N is greater than or equal to 0. Answer this. Okay. Very good. Very good. There is more than one comparison, right? Obviously, regular languages cannot do any comparison, and context-free languages cannot do more than one comparison. But context-sensitive languages can do any number of comparisons. Therefore, it is context-sensitive language. Context-sensitive language. Tell me about this. A power 2m plus 2, a power 2m plus 2, b power 3m plus 4, b power 3m plus 4 such that n comma m greater than or equal to 0. A power 2m plus 2, b power 3m plus 4 such that n comma n is greater than or equal to 0. M comma n is greater than or equal to 0. Definitely there is infinite language. Infinite comparison is required. Infinite comparison is required. Therefore, it is not regular. Infinite comparison is required. Therefore, it is not regular. Infinite comparison is required. Therefore, it is not regular. Right, right. But then if you observe it, there is only one comparison required. I have to compare this with this. There is only one comparison required, है ना? There is only one comparison required. Therefore, it is context-free language. Therefore, it is context-free language. Right, right. Later, I will show you how to prove that it is context-free language. I'll just give you some hint. You can write it as a power 2m, a, bb, bb, b power 3m, right? And then you can convert it into a grammar. Okay, I will show you this later. We will do this later, not now. For now, just use the rules of RBR. You use the RBR rules and you understand it. Okay. Don't write about anyone else in this. You will get blocked. Okay. Don't talk about any other coaching center or any other teacher in my classes. Okay. ये क्लास तो मेरा राज है, डरने की क्या बात है. ठीक है. a power n square, b power 3n plus 4, a power n square, b power 3n plus 4 such that n is greater than or equal to 0. a power n square, b power 3n plus 4 such that n is greater than or equal to 0. Such that n is greater than or equal to 0. So, comparison is required. Therefore, this is not regular, but this is a non-linear form. है ना? Even context-free grammars cannot do non-linear form. Even CFGs cannot do non-linear form. Therefore, this is not context-free grammar also. This is not context-free language also. This is not context-free language also. This is not context-free language also. Right. Now this is context sensitive language. Now this is context sensitive language. This is context sensitive language. Right? 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 A power m, b power n, c power p such that m is equal to n or n is equal to p. M equal to n or n equal to p. I will give you proofs. We are not yet done. We are not yet done. I will give you proofs. Don't worry. We still have a lot of classes. By the end of all classes, you will understand everything. Okay? By the end of all classes, you will understand everything. So, m's have to be compared with n or n's have to be compared with p. Definitely one comparison is involved. Therefore, this is an infinite language. Okay? This is a infinite language. This is a infinite language. 1 minute. I think it is raining heavily. 1 minute. So what we need is one comparison at a time. One comparison at a time. What we will do is, in one path we will test for m equal to n, and in other path we will test for n equal to p, right? One comparison at a time. Therefore this is context free language. Therefore this is context free language. One comparison at a time is required. Therefore this is context free language. Okay? Now I'll change the question a little bit. A power m, b power n, c power p, such that m equal to n and n equal to p. n equal to p. So these two have to be equal and these two have to be equal. What kind of language is this? What language is this? What language is this? Very good. Actually, you can write this language as a power n, b power n, c power n. है ना? So this language is nothing but CSL. You need more than one comparison. You need more than one comparison. That is why the language is CSL. That is why the language is CSL. Right? 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 Now, RBR rule number 2D. RBR rule number 2D, string matching. String matching. ठीक है? What is WWR such that W belong to A comma B star? What is WWR such that W belong to A comma B star? What is WWR such that W belong to A plus B star? What is WWR such that W belong to A plus B star? Very good. This is a palindrome, है ना? This is a palindrome. This is a palindrome, right? And in fact, this is even length palindrome. In fact, this is even length palindrome, right? In fact, this is even length palindrome, isn't it? So whenever it is a even length palindrome, regular language cannot do it. Regular language cannot remember W and compare with W power R, but context-free languages can do it. Context-free languages can do it. Okay? Okay? Now if I write like this, WA, WR, union, WB, WR, such that W belong to A comma B star, such that W belong to A comma B star. What is this language? WA, WR, union, WB, WR, such that W belong to A comma B star, such that W belong to A comma B star, such that W belong to A comma B star. What is this language? Can you tell me what the language is? This is set of all odd length palindromes. Set of all odd length palindromes. Regular languages cannot do it, but context free languages can do it. If I union these two, this one and this one, if I write like this, WWR union WA WR union WB WR WB WR WB WR, right? What is this? This is set of all palindromes. This is set of all palindromes. Hannah. So this cannot be regular. This cannot be regular. This can be context-free language. This cannot be regular, but this can be context-free language. This can be context-free language. This can be context-free language, right? Now, what about this? WW such that W belong to A comma B star and mod W equal to 10. WW such that W belong to A comma B star and mod W equal to 10. Mod W equal to 10. WW such that W belong to A comma B star such that mod W equal to 10. Yes, it is because of the comparison. What is WW? W has to be a string and other W has to be a string. You can directly answer it. Very good. Bharanidharan. Bharanidharan has answered it very fast and very accurate. So this language is finite, right? This language is finite. Therefore, this language is regular. This language is finite. Therefore, this language is regular. If I write like this, WW such that W belong to A comma B star. WW such that W belong to A comma B star. W belong to A comma B star. A comma B star. WW such that W belong to A comma B star. Very good. W has to be compared with W. This kind of comparison cannot be done with regular, and this kind of comparison cannot be done with context-free languages also. This I will tell you later. Why it is not CFL, I will tell you later. Why it is not regular, you know already. You know already why it is not regular. I will tell you later why it is not CFL. I will tell you later why it is not CFL. I will tell you later. Okay? I will tell you later why it is not CFL. Why it is not CFL. Right? WW such that W belong to A comma B star is not regular, not context free, but it is context sensitive language. Context sensitive language. Okay? You can remember all these rules. I will give you all these rules at once. WWR such that W belong to A comma B star. A comma B star. In this, mod W equal to 10, mod W less than 10, mod W less than or equal to 10, mod W not equal to 10, mod W is greater than 10, mod W is greater than or equal to 10, mod W is greater than or equal to 10, mod W is greater than or equal to 10. Okay, so all these languages are regular. Why? Because they are all finite, है ना? All these languages are finite, therefore they are regular. Now all these languages are infinite, therefore they are not regular. All these languages are infinite, therefore they are not regular. Therefore they are not regular. Therefore they are not regular. Okay? Okay? Now if you observe this, W W or W such that W belong to sigma star. Such that W belong to sigma star. What can you say? W or W such that W belong to sigma star. W belong to sigma star. What can you say about it? No, Aniruddha, we cannot prove by complement. सर अभी से गेट 2026 पॉसिबल है. प्लीज रिप्लाई. प्लीज हेल्प सर. यू आर माई इंस्पिरेशन. अभी से आप सीरियसली प्रिपेयर करेंगे. गेट 2026 इज वेरी इजी. ठीक है. गेट 2026 इज वेरी इजी. ठीक है. सो दिस इज नॉट रेगुलर. रेगुलर लैंग्वेज तो कंपेयर नहीं कर पाएगा. एंड इधर ना वी नीड वन कंपैरिजन हियर and we need one comparison here. Two comparisons are required. Therefore, this is not context-free language. 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 Right, right. But it is context-sensitive language. But it is context-sensitive language. But it is context sensitive language. Got it? If I write like this, W1, W1R, W2, W2R. What is this language? W1, W1R, W2, W2R. What is this language? W1, W1R, W2, W2R. What is this language? क्या करूं भाई, मेहनत तो करना पड़ेगा. जब तक है जान, जब तक है जान. ठीक है. तो इसमें ना एक्चुअली दिस इज नॉट रेगुलर because we need comparisons. Therefore, it is not regular. It is not regular because we need comparisons. Because of comparisons, it is not regular. Because of comparisons, it is not regular. Because of comparisons, it is not regular. Right. Because of comparisons, it is not regular. Because of comparisons, it is not regular. Because of comparisons, it is not regular. But then only one comparison at a time. First you compare W1 with W1R, then you compare W2 with W2R, which means we need only one comparison at a time. We need only one comparison at a time. At a time we need only one comparison. At a time we need only one comparison. है ना? At a time we need only one comparison. One comparison. Right? Therefore, what can we say? At a time we need only one comparison. Right? At a time we need only one comparison. Therefore, we can say it is context-free language. Context-free language. Context-free language. Right? Right? So, these are all the rules. I have given you all the RBR rules. All the RBR rules I have given you. Now you can say whether a language is regular or not. Okay? And there are 4 tables. RBR table 1, RBR table 1, RBR table 2, RBR table 3, RBR table 4. There are 4 tables you have to by heart. From all these you will get at least 2 questions. From all RBR rules and RBR tables you will get at least 2 questions. Okay? Okay. Now let us see one theorem, one lemma which is not very helpful for us. Pumping lemma. Pumping lemma for regular languages. Pumping lemma for regular languages. What does pumping lemma for regular languages say? Okay, let's take a break for 5 minutes. After that, I will continue. Okay, let's take a break for 5 minutes. After that, I will continue. Don't go anywhere. Class is going to be interesting. अभी तो पार्टी शुरू हुई है. ठीक है, अभी तो पार्टी शुरू हुई है. My date of birth is August 31st. August 31st is my date of birth. I am Virgo. Okay. And I don't know much about astrology. You tell me if Virgo is good or not. Okay. Okay. So we will see what is pumping lemma for regular languages. So actually pumping lemma is a negative test. Pumping lemma is a negative test. Okay. If you have pumping lemma, let us say this is pumping lemma. Okay. And let us say there is a language L1. There is a language L1. If L1 is not able to pass pumping lemma, then we can say that L1 is not regular. L1 is not regular. If L1 passes pumping lemma, if L1 passes pumping lemma, then L1 may or L2 लिखेंगे, ठीक है. If L2 passes pumping lemma, L2 may or may not be regular. L2 may or may not be regular. ठीक है, ठीक है, ठीक है. So pumping lemma is basically useless. Pumping lemma cannot say whether a language is regular or not. It will only say if a language is not regular. So pumping lemma is basically useless for us. That is why I have given you rules. Remember RBR rules. Remember RBR rules, right? Rule number 1 is if the language is finite, it is always regular. Rule number 2A is non-linear powers. Non-linear powers. And rule number 2B is, what is rule number 2B? Rule number 2B is, I forgot rule number 2B. Rule number 2B is addition, subtraction, division, multiplication. And rule number 2C is comparison. Rule number 2C is comparison. And rule number 2D is string matching. String matching. Bus. You will get only these questions in the exam. And RBR rules are more powerful than pumping lemma. Okay? Are more powerful than pumping lemma. You will be able to say whether a language is regular or not. But still, you need to know about pumping lemma because in exam they may ask you some theory questions about pumping lemma. In exam they may ask some theory questions about pumping lemma. Okay? In exam they may ask theory questions about pumping lemma. Okay? So pumping lemma for regular languages. Write down whatever I am writing. I will explain you. Okay? నా చెలి రోజావే నాలో ఉన్నావే నిన్నే తలిచేనే నేనే తెల్లవారితే కనురెప్పల తొలి మెలకువ నువ్వే నా గుప్పెడు గుండెల్లో చిరు చప్పుడు నువ్వే పొలమారితే నీ మనసుకి అది నా పొరబాటే నీ పేరే పలకడమే పెదవుల కలవాటే వెన్నెలలా ఉంటుందే నీ పక్కన చోటే వేకువలా చూస్తోందే నువ్వు నడిచిన బాటే ప్రాణాలే తీస్తుందే నీ ఊహలతోటే నీ మనసే నాదాయే వినదే నా మాటే ఎవరే ఎవరే ప్రేమను మాయంది ఎవరే ఈ హాయికి హృదయము చాలంది. Copy this, I will explain. Okay. నిన్నే తలిచేనే నేనే కళ్ళల్లో నీవే కన్నీట నీవే కనుమూస్తే నీవే ఎదలో నిండేవే కనిపించవో వినిపించవో తోడు నా చెలి రోజావే నాలో ఉన్నావే నే తలిచేనే నేనే చెలియ చెంతలేదులే చల్లగాలి ఆగిపో మమత దూరమాయనే చందమామ దాగిపో కురుల సిరులు లేవులే పూలవనం వాడిపో తోడు లేదు గగనమా చుక్కలాగా రాలిపో. ठीक है, this is the pumping lemma. I will take an example and explain you. ठीक है, I will take birthday gift to RBR sir. As I said, I spontaneously regarding mentioning birthday. ठीक है, ठीक है. So I will explain you this. Now what does pumping lemma say is, let us take a language L equal to a power n such that n is greater than or equal to 0. ठीक है, I will take a very big string. I will take a very big string and I will take a part of it and I will pump it. Pumping means repeating it. I will pump it. Then what do I get if I pump it one time? I am going to get a. If I pump it one more time, what do I get? A, right? Now I am going to get all these strings in the language. This string is also in the language. This string is also in the language. What did I do? I have taken a very big string and I have taken a part of it and I pumped it. Pumping means repeating it. When I pumped it, I am getting all these strings in the language. Therefore, this language L1 passes pumping lemma. And I told you that if a language passes pumping lemma, we cannot say anything about it. It may or may not be regular according to pumping lemma. है ना? So, according to pumping lemma, L1 may or may not be regular. L1 may or may not be regular. That is why this is useless. That is why you have to follow RBR rules. What does RBR rule say? RBR rule says that L1 is clearly regular. L1 is clearly regular, isn't it? Now let us take one more example. L2 equal to a power n, b power n such that n is greater than or equal to 0. Right? Take a very big string. 1, 2, 3, 4, 1, 2, 3, 4. Now where should I pump? If I pump this A, I will get extra number of A's, which means that string will not be in the language. If I pump here, I will get extra number of B's, which means those strings will not be in the language. Now you may say that, sir, why don't we pump A and B together? Okay, I can pump. Why don't we pump A and B together? If I pump A and B together, what do I get if I pump one more time? A, B, A, B, 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 A, B, A, B, 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 A, B, A, B, 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 right? So whatever this language is, whatever this language we got is not is in the language. Therefore, this language fails pumping lemma. We cannot pump anywhere and get these strings in the language. This language fails pumping lemma. So what can we say now? If the language fails pumping lemma, we can say that it is not regular. It is not regular. But you don't have to do all this. I have already given you RBR rules. If you use RBR rules, what is RBR rule that applies here? Comparison, right? 2C. RBR rule 2C, you will say that it is not regular. Directly you can say that it is not regular. Isn't it? Isn't it? Right? Now if I give you one more language, L3 equal to A power n, B power n, C power n, such that n is greater than or equal to 0. Take a very big string A, B, 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 C, 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 C. You pump anywhere, you take B's and C's, pump anywhere, you are not going to get this string in the language. Therefore, this language fails pumping lemma. This language fails pumping lemma. Clearly, this language fails pumping lemma. Hana. Therefore, this language is not regular. Therefore, this language is not regular. Okay? Let's revise what we have seen so far. Let's revise what we have seen so far. Okay? So we have to talk about Prafulla Chandra Ray, father of India's chemical industry. Dr. Prafulla Chandra Ray is born in 1861 and he died in 1944. He founded Bengal Chemicals and Pharmaceuticals in 1892. India's first pharmaceutical company is established in 1892. After studying in Edinburgh, he returned to Kolkata to develop affordable indigenous drugs manufacturing using local raw materials without importing anything. Till then, we were importing the medicines, but he has built a company where without importing anything, we are able to make the medicines. He pioneered formulations for compounds like calcium carbide and analgesics, drastically cutting down imports dependency. Ray also established advanced research facilities and mentored a generation of Indian chemists. His entrepreneurial spirit and scientific leadership laid the foundation for India's modern pharmaceutical and chemical sectors. He is a hero for me. He is the Indian. He is a hero for me and he is a hero for all of you. Jai Hind. Jai Hind. Jai Hind. See you tomorrow, guys. See you tomorrow at the same time. Okay? Jai Hind. All of you type Jai Hind. Okay? Thank you so much. Please open Telegram channel. Please open Telegram channel. Am I audible now? Am I audible now? Please open Telegram channel and write about today's class. How today's class is. Did you like RBR rules or not? Please open Telegram channel and write about how much you liked RBR rules. How much you liked RBR rules. Please open Telegram channel and write about it. Okay. Okay. I'm reading your comments. Don't write a single line, write a paragraph. Please write a paragraph about how the class is today. Okay. Good night, guys. Thank you so much.